Hey people, it's Niyas talking. So there's some Daily Mail. Scientists have revealed plans to bring back the extinct island rat 119 years after it was wiped out. In a new paper, an international team of academics outlined how the use of CRISPR, a gene editing technique that can cut and paste small sections of DNA, deleting or repairing flawed genes, could lead to the rat's de-extinction. Scientists would use CRISPR to edit the DNA of a living rat species to match that of the Christmas Island rat, although the new creation may have some differences compared to the original species. Rattus mcleary, commonly known as the Christmas Island rat or mcleary's rat, was a large rat endemic to Christmas Island on the Indian Ocean, but it was driven to extinction at some point between 1898 and 1908, possibly in 1903, like the diseases brought over on European ships. The new study has been led by evolutionary geneticist Dr. Tom Gilbert at the University of Copenhagen, who is planning experiments to de-extinct the Christmas Island rat in the near future. However, he told Mail Online that the issue of bringing back the Christmas Island rat from the dead is far from simple. The tools are now in theory available that people could use to bring things back. For example, labs are trying to use gene editing to change elephant genomes to add mammal-specific mutations, Dr. Gilbert said. I remember that. I did a story on that. If you were to try to use genome editing to change the genome of a living species into a genome of an extinct one, you'd only be able to make some of the changes, not all, so you'd end up with some kind of hybrid. And that raises the question, what's the end goal? If you want a hybrid, go for it. If you want the pure lost form, you're going to be disappointed. Since becoming a popular concept in the 1990s, de-extinction efforts have focused on grand animals with mythical stature. Examples include the dinosaurs, which went extinct 65 million years ago, mammoths 4,000 years ago, and the dodo, extinct by 1681. Theoretically, once the DNA has been sequenced as best as possible and the genome matched against the genome of a small similar living species, experts could identify the parts of the genome that don't match up and edit them using CRISPR. When sequenced the genome of an extinct living species, scientists face the challenge of working with degraded DNA, which doesn't yield all the genetic information required to reconstruct a full genome of the extinct animal. Fortunately, with the Christmas Island rat, Dr. Gilbert and his team was able to obtain almost all of the rodent's genome, its complete set of genetic information. The Christmas Island rat belonged to the Rattus genus, to which modern-day species still belong, including Norway brown rat. Since the Christmas Island rat diverged from other Rattus species relatively recently, it shares about 95% of its genome with the Norway brown. It was quite a nice test model, said Dr. Gilbert. It's the perfect case because when you sequence the genome, you have to compare it to a really good modern reference. For the study, the researchers extracted and sequenced ancient DNA from 2 dry preserved skin samples of the Christmas Island rat, originally collected between 1900 and 1902 and held as part of the Oxford University Museum of Natural History collections. After the team sequenced the Christmas Island rat genome and mapped it to the reference genomes of different Rattus species, a few key genes were missing, they found. Our analysis shows that even when the extremely high-quality Norway brown rat is used as a reference, nearly 5% of the genome sequence is unrecoverable, with 1,661 genes recovered at lower than 90% completeness and 20% completely absent, they say. And that rat picture is pretty terrifying and gross. The missing genes were related to olfaction, meaning that a resurrected Christmas Island would likely be unable to process smells in the way it would have originally. So as it stands with current technology, it may be impossible to ever recover the extinct rat's full sequence, as there will always be some kind of hybrid, according to Dr. Gilbert. It is very, very clear that we are never going to be able to get all the information to create a perfect recovered form of an extinct species, he said. A reconstructed Christmas Island rat could lack attributes likely critical to surviving in its natural environment, the team said. Conversely, it could potentially maintain the immune genes of the Norway brown rat, which would give it some additional potential benefits. Researchers believe this because one hypothesis of how the Christmas Island rat was driven to extinction is that an infectious disease was introduced to the island by Norway brown rats. If this was the case, the pathogen that caused this disease was deadly for the Christmas Island rat, but not for the Norway brown rat. In the near future, Dr. Gilbert plans to try doing the actual gene editing on rats, but would like to start with species that are still living. He intends to begin by doing CRISPR edits on a black rat genome to change it to a Norway brown rat before attempting to resurrect the Christmas Island rat. Though a replica will never be perfect, the key is that scientists are able to edit for the DNA that makes the extinct animal functionally different from the living one. Dr. Gilbert said that in order to make an ecologically functional mammoth, for example, it might be enough to edit elephant DNA to make the animal hairy and able to live in the cold. If you're making a weird, fuzzy elephant to live in a zoo, it probably doesn't matter if it's missing some behavioral genes, he said, but that brings up a whole lot of ethical questions. Though he is excited about his future research, the whole process sometimes gives him second thoughts. I think it's a fascinating idea in technology, but one has to wonder if that's the best use of money as opposed to keeping the things alive that are still here, he said. Yes, this is a massive waste of money doing things that nobody asked for and nobody really needs. CRISPR-Cas9 is a tool for making precise edits in DNA discovered in bacteria. The acronym stands for Clustered Regularly Interspaced Palindromic Repeats. The technique involves a DNA cutting enzyme and a small tag which tells the enzyme where to cut. A DNA editing technique called CRISPR-Cas9 works like a biological version of a word processing program's find and replace function. There's an image here that I can't really show you, so I'll leave the link and you can look at it and you'll see it yourself. By editing this tag, scientists are able to target the enzyme to specific regions of DNA and make precise cuts wherever they like. It has been used to silence genes, effectively switching them off. When cellular machinery repairs the DNA break, it removes a small snip of DNA. In this way, researchers can precisely turn off specific genes in the genome. This approach has been used previously to edit the HBB gene responsible for a condition called B. thalassemia. Well, that's the end of the article. So, you've all heard this disturbing Frankenstein Jurassic Park story. So, please leave your comments. If you would like to subscribe to this channel, subscribe to my backup, I'll leave that in the pinned comment. If you'll, please sub to this channel. Please subscribe to my Instagram. I'll leave that in the comments. If you'd like to buy one of the t-shirts, I'll leave that there as well. Peace.